Alright guys, so today what we're going to do is just really quickly go over chapter 8, which is on tolerancing. I'm not going to cover everything that this textbook does cover, purely because you are already covering it in class, so it would be kind of repetitive. I'm just going to show you guys how to take what you've learned in class and put it on the inventor drawings that you'll be creating for your course project and your CAD quizzes and things like that. So, I just created two really simple parts that we're going to be working with to show you guys how to do these drawings. So first thing we're going to do is create a new drawing. We're going to be working with millimeters because that's what I made this in. And we've already gone through this, make sure you change your sheet size. I see sometimes some of you forget to do that. It is important that you change your sheet size. You don't want a huge sheet for something that just doesn't require it. So you can pull all of these down. There's already like pre-formatted things, but we're going to change our title block as well. And now what we're going to do is just come in and throw in the piece that we want to work with. So we're just going to throw this in here and we'll just project it. And I'll make this scale bigger in a second. How big is that? We'll go with 1.5. Alright, move this all in, and we can go in here and make that look like that. Alright, so I'm just going to throw a few dimensions on this because that's what we're going to be working with in this case. So, first thing we're going to want to do is consider our tolerances. So you have different types of tolerances. You have unilateral, bilateral, things like that. So they're called something a little bit different in the inventor itself. So the first thing that we're going to do is do our plus and minus tolerances. So here we have the regular thing that opens up when you create a dimension on your drawing. So as you know, you can come in here, you can type in things before and after, just to make it easier on yourself. So if you have 3 holes, you can type in 3 times whatever and dimension the same hole only once, things like that. So for plus and minus tolerancing, what we're going to do is work with our symmetric, okay? And we're going to come in here and we can just throw in whatever tolerance we want. So for our cases, we're just going to throw in 0.03 and we'll click OK, and we'll have this plus or minus 0.03 dimension for this part of the piece right here. So you can also do something that's pretty helpful if you're going to be using it for your whole a drawing. If you are going to use the same thing for your whole drawing, you can come up here and you can go under dimension, go to your default, and actually create the tolerance, your default tolerance, depending on what you're working with. So here for our symmetric, we can come in here and we can just type in 0.03. You can save and close, and then when we go and create a new dimension, it'll automatically have that there for us. So that's pretty helpful, but we're gonna refrain from doing that right now. So I'll go back in and switch it up for us, and we're just going to go back to default and we're just going to go back to symmetry, click 0, and we'll go to default and do save and close. So another thing that you can do your stacked tolerances. These are like your limit tolerances, and so what we're going to do is let's do another dimension. Let's dimension up right here, and we're going to come under tolerance and we can do limit stacked. And so that'll literally, what you're going to put in is literally the maximum and the minimum. So we'll make this 30.5 and we can make this 29.5, and we'll click OK, and that's how that is going to show up there. That really depends on what you're looking for, what you're being asked to do. Similarly, we can do things with our angular dimensions. So let's come over here and create another drawing. I'm just trying to show you guys how to do something so it's not anything too complex of a, you know, part, just so I can show you what you're doing. So we're going to come in here, throw in our regular title block. Let's change that to 10. Click OK. We'll drag this over here. Projected view, projected view, projected view, and create. And we'll just drag this around however we think is best, and we can make this a little smaller, make that smaller. So now I'm just going to show you guys again how to come in here and do the angular dimension. So what you're going to do is, you know, click, like, you know, oh, that went off a point. Make sure you don't click on these green dots. Click off of, you know, the parts that you're referencing your angle from, and you can come in here and decide what type of limit you want to do, or tolerance you want to do. So you can do a symmetric tolerance, so we'll go 0.5. So as you can see, I put 0.5, but it is only giving us plus or minus 1. So that is because if you look under your angular tolerance, you can see that we have it set to 0, so it wasn't giving us our 0.5. Now it gives us our 0.5 when we change our angular tolerance. You can also change your units, so your tolerance doesn't have to be the same as your units, but you can. And look at that. So now we can also do deviation. So this would be like, let's say that you can, you know, go up from what you have dimensioned, you can go up 0.5 of a degree, but for your lower bound, you can only go 0.25 of a degree. That's how you would do that. You know, there's just, it's all stuff that you guys have been learning in class. It's just, this is how you're going to do it in, there we go. This is how you're going to do it in Inventor. So you have your limits, fits, things like that, your max, your min, all of that fun stuff. So now what I want to mention is just that you shouldn't dimension the same distance twice. Don't dimension the same distance twice. If we already have this dimension here, we don't necessarily need it here. Okay? This is the same dimension. I would not dimension that again. However, you don't know this distance, and you don't know this distance, and you don't know this distance. So you might think, okay, like, let me come up here. I'm going to dimension this here, and let's say that the tolerance is symmetric, and we're going to give it 0.1. Okay, now let's say we do the same thing here. We're going to do symmetric, and we're going to do 0.1. What you might want to do in this case is come up here and dimension this part as well, but you can see this is already dimensioned. So based off of this, you should be able to tell what this distance is. Another thing that you might see is that this has a tolerance of plus or minus 0.5 here. So if we were to change this and go into our symmetric, it would be plus or minus 0.5. Whereas this, if I was to delete this and I dimensioned here, here, all three of these, and gave them all asymmetric plus or minus 0.1. And again, this looks very messy, and that would also depend on how you would dimension something. But let's say I came in here and wanted to do that. If we were to take these dimensions up here and leave this on the drawing, we would have a total tolerance at the end of plus or minus 0.3, whereas down here we'd have a total tolerance with just this of plus or minus 0.5. So what you want to take into consideration in this case is how you are dimensioning your drawing. Okay, so if we gave every dimension a point plus or minus 0.5, let's say we've just decided everything has a plus or minus 0.5. Okay, you'd have a total dimension here, or tolerance of plus or minus 0.5, and you'd have a total tolerance once you added this up as plus or minus 1.5. That's going to be different, and one isn't necessarily wrong and the other isn't necessarily right. It comes down to how are you manufacturing these things? What is more important? Is that total distance more important? Is it more important that you have a tight tolerance on this gap here? Or this part here? What is more important? Can this be longer as long as this is within range? that comes down to your product design. That comes down to a lot of different things. So just keep that in mind. But the important thing to note here for our purposes is if this is dimensioned here, you don't need to come up and dimension all three of these up here. You can decide to not dimension one of these. So for simplicity's sake, let's say that this gap isn't very important to us. It's these two prongs here. This gap doesn't matter. So you can come here, make that look nice, plus or minus, and you can have this one down here as well. Again, this would change, these tolerances, everything would change, but that's what you would be working with. So this is just very basic. Again, go off of what you are being taught in class as well, because that will be helpful in the long run. Another thing that we can talk about is chain dimensioning versus baseline dimensioning. So this is another good example here. Let me delete this. We have these three things that could be dimensioned. Let me delete this as well. We have these three parts right here that can be dimensioned. So chain dimensioning would be to dimension off of each one. So I won't throw any tolerances in this right now, just for simplicity's sake. So this is chain dimensioning. And I'll make that look nicer in a second. Because this is so small, it's hard to fit in there, but you can change that with your styles and things like that. But let's just say this is chain dimensioning. Okay, obviously you would want these to be in line. This could change depending on how you have your styles, things like that. I mean, if we increased this scale, that might help as well. Yeah, there you go. Increasing the scale will help get these actually in their spots. But you would want these all to be in the same line. Sometimes it could be a little finicky, but in general. So this is chain dimensioning. It's dimensioning this piece from this line, this middle 10 off of this left-hand side line on your part in your indent, and then this right 10 is going to be dimensioned off of this right-hand side line of this indent. That's going to be your chain dimensioning. Your baseline dimensioning, and I'm just going to move this to make it easier. That's not what it should look like, but just to show you. Baseline dimensioning would be to take each one of these dimensions off of a baseline. So we would measure all of these dimensions off of that baseline. Again, that comes down to your purposes. It comes down to what's easier, what looks better, what your place of work wants, things like that. Okay, so another thing I'm going to show you guys how to do is just do your surface control symbols, and these are just to show you, these just show what the surface finish should look like. So you can come in here and you can just click on the actual leader line of this part and click create, and you can come in here and there's a bunch of different surface types. So this surface type here tells you the surface finish specified. So if we were to use this and then put this in, it would say it was about like 0.8. So that's here we go, the roughness average max. This is the removal of the material required, so what material needs to be removed by machining. You can put in a number for that as well if it's specified, and this indicates that there is no removal of material there. There's also a few other things that you can throw in depending on what you're working with. So yeah, if you hover over these, I don't know if you're covering these in class. If you aren't covering them in class, then you know, you don't have to focus on this too much, but if you are, then that's something that you should look into. You would know what these symbols are. You could throw them in there, perpendicular, things like that. So I can just click OK, and that will give me a surface finish of 0.8. That's the average roughness, and it would have no direction. That's what this M means. So another quick and easy thing that we can do is just do our datum. So you can just come under here, under annotate, same place where the surface was located, but you can pull it down. is your datum. So you can just go off of whatever, it depends on, you can go off of your leader line if you want to, click continue, and that would be your datum A, things like that. So that's not what I want to do. Click again. There you go. And that will be your datum A. Things of that nature. We can also throw in a, let me do another dimension really quick. We're just going to delete that. We can also come in here and throw in a feature control box. Click OK. So what we're going to do is, in the same place, we have this feature control box, and we can just click on the actual dimension and click continue, and that will give us our control box right there. So this, again, these symbols are here. You know what these symbols are. We can go in and change them. I think if you hover over them, it should, yeah, it'll tell you what each one of these means. So we could say perpendicularity. Again, these are, you can come down here and put in your symbols that correspond to what you need. There's the diameter symbols, tolerances, different things like that. So yeah, you could just throw in whatever you want, your different tolerances, things like that. For the actual circle itself, if we were to dimension it, there we go, throw in that dimension, click OK. We can come in here and again create our datum, click continue. Oh, I did that off of the middle. Whoops. Or go off of our dimension, click continue, and we could come in here and have our positional tolerance, put in our, where is it, diameter symbol, things like that. Throw in whatever fits for what you're working with. So that's just how you throw those in. Again, you learn about this in class, so just go off of what you know in class and what you would work with in that case. The last thing I'm really going to show you guys how to do is go in here and just create a basic dimension, and those are just for your geometrical tolerancing as well. So yeah, there's nothing too difficult in this chapter. So it really depends on what you're working with, what your tolerances are, how you plan to manufacture it, things like that. So let's make this smaller again. And we'll move it up just to make our lives a little easier. But yeah, don't double dimension anything. And the last, I said the last thing I was going to show you. The last thing I'm going to show you, because I think a few people just missed it. This is where you go for your project to change stuff in your title block. Please change this. Please read the instructions and change this, because some of you guys have been leaving this out and it's pretty important. So make sure you do that. Thank you. Another quick and helpful thing that you guys can do if you want to make like tables or anything like that, just to throw in like your parts and such, you can come in here and just honestly just create a table and throw it in somewhere, and you can go in, edit what it says, things like that, name the columns, number them, and that could help you at some point if you want to throw in like different tolerances and things like that. So that's just a little feature that it has for your convenience. But yeah, other than that, we pretty much covered what we need to cover in this class with regards to just drawings, dimensioning, and things that pertain to what you're learning in 305. But if you have any questions, please let me know.